All right, so now we're ready to look at some more of our case studies. So in case study 3, I want you to go ahead and read that. You can pause the video and do that. Okay, so I'm going to assume that you've paused and read. So what are our hypotheses? So if we read about this question, we see that Mr. Burns is concerned that less people may be taking out loans. So he wants to decide if less, he wants to test if less than 15% of the customers have loans. So our null, of course, is going to be that nothing's happened. The population proportion is still 15%. Oh, it thinks I want pi the number. It's funny. Okay, and of course the alternative is that what we're trying to test. He's trying to show that pi is actually less than 15%. Again, we look at the numbers here, right? So this is our sample size. This is our sample percentage. This is our alpha. And of course, this is pi naught. So we know that our sample size is going to be 900. The sample percentage we got was 10%. And again, notice how that the estimate is always in favor of the alternative, right? We're trying to prove that pi is less than 15%, so pi hat has to be less than 15%. Okay. What is our null distribution? Let's just check that the central limit theorem conditions are met. So first of all, do we have a random sample? And the answer is yes, because this is given in the problems. Right? Is our sample size large enough? Well, we have to check and see if n times pi naught is greater than or equal to 10, and it is. If you take 15% of 900, right, you'll get 60, so that's okay. And we also have to make sure that n times 1 minus pi naught is greater than or equal to 10. And obviously this is going to even be bigger than n times pi naught, so this is obviously it is. Okay. Is it too large? Well, we have to assume that the bank has 9,000 customers, and we're going to assume that. That's not at all unusual. Okay. So now we know what our null distribution is, right? We know that since the central limit conditions are met, we know that if the null is true, then what estimators look like from the null they have a normal distribution. They're centered at pi naught, and we take the square root of pi naught times 1 minus pi naught divided by n. So that's what estimators should look like. Or in other words, if we start to kind of put in numbers now, right, we know that pi hat's coming from a distribution with the null hypothesis is true, and in particular in our case, they're going to be centered at 0.15, and they're going to have a standard deviation 0.15 times 0.85 divided by 900. And we're going to use this distribution now to judge our sample percentage and see if it looks like it could come from this distribution. So we can go back now to our book that our example that we had here, right? And we're doing a lower tail test again, right? So we have a sample size of 900. So our samples, all we have to do here is change the, oops, sorry, I'm in the wrong one. Make sure that you're in the right one. Okay, I want to do a hypothesis test for pi, not mu, so be careful. Okay, so this was our input here that we needed. Here I have a sample size of 900. I don't need a number of successes because I'm given pi hat 0.1. This is 0.15. And I'm just going to use the same formula. Square root of pi naught times the quantity 1 minus pi naught divided by the sample size. And there we are. And so if we think about this for a minute, right? Basically this says that if we kind of sketch this out, this tells us that if the null hypothesis is true, this is what our distribution looks like. It's centered at 15%, and the standard deviation is roughly about 1%. So 16, 17, 18, 14, 13, 12. This is what pi hats look like if the null hypothesis is true. So this is 14, 13, 12, 16, 17, 18. And our value is way down here at 10. Okay? So we already know without even running a hypothesis test, without doing the calculation, that the answer is going to be the probability is going to be very low. The p-value, the area, and this tail is going to be very, very low. Let's just go ahead and compute it though. So we're doing a lower tail test, so we're computing the probability in the lower tail, which means we're using norm.dist, right? So norm.dist, let's see, there's our sample estimator, the mean, the standard deviation, and then true. And we can see that the p-value, this is expressed as a percentage, is way lower than any alpha. Alpha is always 1, 5, or 10%. So this is way, way lower than any alpha, right? So we can go back now and make our statistical decision. P-value, which is equal to 0.0013, right? Very, very small, is less than any value of alpha we could choose. In this case, it's an alpha of 1%. By the way, this is a percent, okay? It's important to always keep that in mind. So this means that we're going to reject the null. P-value is too low. Okay? And actually, this belongs up here. This is our statistical decision, okay? Which is different than our conclusion. So our conclusion is now where we state, where we essentially answer the question, right? We go ahead and we state our results in normal everyday language. So we would say at a significance level, of 1%, we find there is sufficient evidence to conclude the alternative, and the alternative in everyday language is that the percentage of customers at the bank holding a loan is less than 15%. To conclude, the percentage of bank customers with loans is less than 15%. Okay? So at a significance level of 1%, we find there is sufficient evidence to conclude the percentage of bank customers with loans is less than 15%. All right, very good.